Reaching for the stars. The importance of space rockets. Space rockets are vehicles designed to travel beyond Earth. They are marvels of engineering, combining advanced technology and human ingenuity to break free from the gravitational pull of our planet. They are essential for space exploration, enabling us to explore planets, moons, and asteroids. Without rockets, our dreams of reaching other worlds would remain just that, dreams. Rockets carry telescopes to observe distant galaxies, providing valuable data about the universe. These telescopes, like the Hubble Space Telescope, have given us breathtaking images and insights into the vastness of space. These incredible machines are at the forefront of our quest to unravel the mysteries of the cosmos. They enable astronauts to travel to the International Space Station, conduct experiments, and even dream of future missions to Mars. Rockets have played a pivotal role in expanding our understanding of the universe. Historic launches, like those of the Apollo missions, have marked significant milestones in human achievement and exploration. They have allowed us to study our own planet from a unique perspective, gathering data on weather patterns, climate change, and more. Satellites launched by rockets monitor Earth's health, providing crucial information for environmental protection. The development and advancement of rocket technology have led to numerous technological advancements that benefit our everyday lives. Innovations in materials, propulsion systems, and electronics have all stemmed from the demands of space travel. From communications satellites that connect us globally, enabling instant communication across continents, to GPS systems that guide our way, helping us navigate from one place to another with pinpoint accuracy, the impact of space rockets extends far beyond the realm of space exploration. They have become integral to our daily lives, influencing everything from weather forecasting to disaster management. These technological marvels have revolutionized communication, navigation, and our understanding of the Earth and beyond. They have made the world smaller, more connected, and more informed. As we continue to explore and push the boundaries of human ingenuity, space rockets will undoubtedly remain an integral part of our journey to the stars. They symbolize our relentless pursuit of knowledge, our desire to explore the unknown, and our unyielding spirit of adventure. The future of space exploration holds endless possibilities, and rockets will be the vessels that carry us there. Newton's third law, the foundation of rocket science. To understand how rockets work, we must first grasp Newton's third law of motion. This fundamental law states that for every action, there is an equal and opposite reaction. In simpler terms, when you push against something, it pushes back on you with the same amount of force. This principle is at the heart of rocket propulsion. A rocket engine burns fuel in a combustion chamber, producing hot gas. This gas is then expelled out of the rocket nozzle at high speed. As the gas rushes downward, it creates an equal and opposite force that propels the rocket upward. Imagine standing on a skateboard and throwing a heavy ball forward. As you throw the ball, you'll notice that you roll backward on the skateboard. This is a demonstration of Newton's third law in action. The force you exert on the ball, or the action, is met with an equal and opposite force from the ball, or the reaction, causing you to move in the opposite direction. Space rocket anatomy: engines, fuel, and payload. Understanding the intricate details of these components is essential for grasping how rockets function and achieve their missions. A space rocket is a complex machine with several key components. Each part plays a vital role in ensuring the rocket can reach space and complete its mission successfully. The assembly process involves meticulous planning and precision engineering. The engine is the heart of the rocket, responsible for burning fuel and producing thrust. This thrust is what propels the rocket off the ground and into space. Without a powerful and reliable engine, a rocket would be unable to overcome Earth's gravity. Rocket engines are designed to withstand extreme temperatures and pressures, as the combustion process generates immense heat and energy. The materials used in engine construction must be able to endure these harsh conditions without failing. The fuel used in rockets can vary, but it typically consists of a liquid propellant such as liquid hydrogen or kerosene and an oxidizer such as liquid oxygen. These substances are chosen for their high energy content and efficiency in producing thrust. The oxidizer is necessary to allow the fuel to burn efficiently in the vacuum of space. In the absence of atmospheric oxygen, the oxidizer provides the necessary chemical reaction to ignite the fuel. These propellants are stored in separate tanks and mixed in the combustion chamber, where they ignite to create the powerful thrust needed to propel the rocket. The precise mixing and ignition process is critical to the rocket's performance. The payload is what the rocket carries into space. This can range from scientific instruments to communication satellites and even human astronauts. The payload's purpose defines the mission of the rocket. This can include satellites, telescopes, scientific instruments, or even astronauts. Each type of payload has specific requirements for protection and deployment, which must be carefully considered during the design phase. The payload is housed in a protective capsule at the top of the rocket. This capsule shields the payload from the harsh conditions of launch and space travel, ensuring it reaches its destination intact. This capsule is designed to separate from the rest of the rocket once it reaches space and to safely return to Earth at the end of its mission. The separation and re-entry processes are carefully engineered to protect the payload during these critical phases. The design and construction of each component are crucial to the success of a space mission, highlighting the complexity and precision involved in rocket science. Engineers must consider every detail, from material selection to structural integrity, to ensure the rocket can withstand the rigors of space travel and achieve its mission objectives. Section 4. Stages of launch. A journey in phases. Launching a rocket into space is a complex process that involves multiple stages. Each stage is like a separate rocket with its own engine and fuel supply. The first stage is the largest and most powerful, responsible for lifting the rocket off the ground and overcoming Earth's gravity. Once the first stage's fuel is depleted, it separates from the rest of the rocket and falls back to Earth. The second stage then ignites, providing additional thrust to propel the rocket higher. This process of stage separation continues until the final stage, carrying the payload, reaches its desired orbit or destination. The multi-stage design is essential for space travel because it allows rockets to shed unnecessary weight as they ascend. By discarding stages as they become empty, rockets can conserve fuel and achieve the incredible speeds required to escape Earth's gravitational pull. This efficient design principle has been instrumental in enabling humanity's ventures into the cosmos. Section 5. Breaking free. The concept of escape velocity. To escape Earth's gravitational pull and reach space, a rocket needs to achieve a specific speed known as escape velocity. This concept is fundamental to space travel and exploration. Imagine throwing a ball straight up in the air. The ball will travel upward, but only to a certain point. The ball will travel a certain distance upward before gravity pulls it back down. This is because the force of gravity is constantly acting on the ball, pulling it back towards the Earth. The harder you throw the ball, the higher it will go before falling back to Earth. If you could throw it with enough force, it would keep going up and up, eventually escaping Earth's gravity. Escape velocity is the minimum speed an object needs to travel to break free from Earth's gravitational pull and never fall back down. This speed is crucial for any object that wants to leave the planet and venture into space. This velocity is approximately 11.2 kilometers per second, or about 25,000 miles per hour. To put that into perspective, it's about 33 times the speed of sound. Achieving this incredible speed requires an enormous amount of energy, which is why rockets are so large and powerful. The fuel they carry is used to generate the necessary thrust to overcome Earth's gravity. Once a rocket reaches escape velocity, it can essentially coast through space without needing to constantly fire its engine. This is because in the vacuum of space, there is no air resistance to slow the rocket down. The absence of air means that once the rocket reaches the required speed, it can maintain that speed with minimal additional energy. Inertia, the tendency of an object to resist changes in its motion, keeps the rocket moving at a constant velocity unless acted upon by an external force, like gravity from a planet or star. This principle is a cornerstone of Newton's first law of motion. Newton's first law states that an object in motion will stay in motion unless acted upon by an external force. In the vast emptiness of space, there are very few forces to slow down a moving rocket. This is why space probes, like the Voyager spacecraft, can travel for decades through the solar system and beyond, powered only by the initial thrust that set them on their journey. Sometimes, spacecraft use a technique called a gravitational slingshot or gravity assist to gain additional speed. By passing close to a planet, they can use the planet's gravity to accelerate and change direction without using extra fuel. This technique has been used in many missions to explore distant planets and moons, making it possible to reach destinations that would otherwise be out of reach with current technology. Understanding escape velocity and the principles of motion in space is essential for planning successful space missions. It allows scientists and engineers to design spacecraft that can travel vast distances and explore the mysteries of our universe. As we continue to push the boundaries of space exploration, the concept of escape velocity will remain a fundamental part of our journey to the stars.